Okay, we got a new project video for you today, and this one was inspired by uh, an amazing YouTube author, Lyle Peterson. He goes by the name, his channel goes by the name of Tubal, and he's also known as Mr. Pete. He's got over 1,300 shop videos on every subject you could imagine, and probably if you found your way here you must know about Mr. Pete. Anyway, he's a young fella just like me, and but even so he's been having some problems moving heavy objects on and off the table of his vertical mill, like vices and rotary tables and other heavy objects. And he designed a thing he calls a Tubal crane, which he can use to pick things up. It mounts right on the table of the mill and swivels back and forth and allows you to pick up heavy objects and set them down. It uses a hydraulic jack and a few other parts, and it works rather well, and was well received by his followers. Here's Mr. Pete and his Tubal crane. But some of them asked why didn't he put the crane, or the Tubal crane, on a cart so that he could pick up things and move it around. In other words, make it more useful, allow it to work on different kinds of things. And he showed some of the carts that he had there and how tipsy and unstable that would be. But as he was doing that, I realized that I had a homemade cart that I had built for another purpose that might be just perfect for this kind of thing. So we'll take a look at that. Here's the cart, and as you can see, it's just built from a bunch of 2x4s and wood screws, and it's got a piece of 3/4 inch plywood for the top. It's about 19 inches deep, and width, counting the 2x4s, is about 16 inches. I think it was primarily determined by, unless my memory fails me, by the size of the piece of plywood I had laying around. But anyway, it was originally built to hold a small arbor press. And when I designed the cart, I decided to extend the legs out from the bottom. And the reason for that was I was concerned that if I had a really whale on the lever on the arbor press, I could pull the cart forward and tip it over right towards me, and that'd probably spoil my whole day. So I decided to give it a little extra length. In fact, the wheels are an extra 9 inches or so beyond the front legs of the cart. And just to give you the rest of the dimensions, the unit is well, it's about 35 inches high, and it worked real fine for the arbor press, and I had it on here for quite a few years. But then sometime later I wasn't using it quite so much, and it got moved off of here, and something else took its place on the cart, and I'll show you that in a second. So here's the rest of the story. In an earlier video, I built this hydraulic press, and it actually is made. Here's a hydraulic jack, and this is the the top of the jack and the surface that it presses against. These two things are a set of punch press dies that I modified a bit to make the press, and that's worked out well for me, and it's the current occupant of my little cart. But one of the things that I wanted to point out, well, first of all, I got most of what I need to build the Tubal crane right here. I got the jack, I got a stand for it. I can take this part off and put on a boom across here, and that would make a pretty nice crane. The nice thing about this cart is this extension that I had made on the front wheels of the cart. That can roll right underneath the table of the mill, and that way the tipping point of the cart is way out here, and and we got this press which weighs about 84 pounds, and the table itself weighs another 37 pounds. So we got a lot of weight coming down at this point, and if we build a boom that comes out here, it can stick actually somewhat beyond where the wheels are, and yet it can roll right up and reach the vise. And I'll show you that in a second. Okay, let's take a look at the parts we needed to make the hydraulic press into a suitable crane. First of all, there's the boom. This was made from a piece of 1.5 square 1/8 wall square tubing that I had left over from another project. And you can see I opened up this end on the mill to mate with the vertical component that is in the back of the crane, and so that was just a simple operation on the mill. And then of course we had to drill a 1/2-inch hole through the side in order to provide a swivel there, and 1/2-inch hole through here, whoops, in the middle, there it is. That's the goes at the top of the hydraulic jack, and on the other end, we open this up to provide a space for the hook, and 1/2-inch hole here, and we got another 1/2-inch hole here, and that's a mistake. So, but it ain't hurting anything, so we left it there. The next part, and the one probably that required the most effort, I had a piece of it's a 2 1/4-inch scrap that I used to make the hinge point for the top of the hydraulic jack, and this has got a hole in it which was bored to match the diameter of the top of the hydraulic jack, and I just turned this down to take away some weight, not really necessary. But then the mill, I used the mill to take the center out of this so that I could form a hinge, with the boom. And then this is the vertical member at the back. That was a piece of 1.25 inch stock that I had laying around, and then for the bottom of that, another small piece of the 2 1/4 inch material, and that bolts down to the surface of the cart, and provides an attachment for this part here. So, and then the only other thing I made were some small spacers. I wanted to use bolts that would allow me to keep all the hinge action on the non-threaded part of the bolt. So I made these to, so I used a little longer bolt that had a unhinged or unthreaded part that was long enough. These are grade 8 bolts that I picked up. Okay. Okay, now let's put this guy together. We'll start with the little clip here that holds the back of the upright that attaches to the boom, and that just, I got a long bolt there, just goes right through the 2x4. If the guy was on the ball, he'd have a hammer here, you know. Need a socket here. The next part is the, what would you call that? I don't know. This is that little spacer I was talking about. I got nylock nuts here, and I can bring them with that spacer. I can bring the nuts right up to the end of the threads, actually, without you'll have some flexibility there. So now the boom. There we go. There we go, finally. Where's my spacer? There it is. Okay, one more little job to do before we test this thing. The hook. This is just kind of a light duty hook that I picked up at Tractor Supply, but it'll do for now. I'm going to look for something a little heavier duty. But you just got a standard bolt to hold this one, and it fits in that little slot I showed you before. All right. Now the next thing we're going to do is give it a test. We got a little handle we built for the jack here. And as I said, this guy will roll right underneath the table, and so you got plenty of room to hook up the vise. And it picks it up quite easily. Now, one way to look at the stability of this thing is to just pick it up a ½ an inch like I did here. It's completely suspended now. And now I can push this thing around this way or this way, and this cart is completely stable. So we can roll this out of here. Now we're going to set it down on a little table I got here. And so we'll replace it with another vise I got. Probably 90% of the time I leave the Kurt vise on the mill, but sometimes you got to clear the deck. So if you got something big or long or flat or complicated or tall that you need to work on the mill, sometimes you got to clear the deck. So that's how we do that. got another vise here. That Kurt vise, by the way, weighs about 70 pounds. This is a Bridgeport vise, and it's got a rotary table on it, and so I do use this one occasionally for special jobs. And put my little clamp in there. Tighten that up. And hook it on. This one weighs over 90 pounds. So let's see how we do this. Guess I better close the valve on the vise here, on the jack. Okay, we got that one suspended, and again, even with the 90-pound vise, we can shake it and it's very stable. We gotta go up a little more. Okay, we'll set it down. And yeah, I know this piece is bending quite a bit. It was the only piece I had that was about the right size, but I'll be replacing that shortly. So there we go. One vise off and the other one on. And for a young fellow like me, that's a real aid. I would spoil my back pretty quick if I tried to pick up either one of these. One other note, pop this one bolt out down here. And this whole assembly comes right off. So now you can pop the top back on here, and you're back to being hydraulic press. So it's a 2-for-1 deal here. Okay, I want to add some observations about the way this thing works, and to show you how you can get in trouble with it if you're not careful. I made a rough sketch of what the cart looks like here, and let me zoom in a little bit. Basically, you got the boom. Where are we going here? Boom is out here, and this vertical line is the pivot point. The pivot point is this. Oops. Pivot point is this front wheel here, and the vertical line traces that up to where it is on the boom. And my boom is about 30 inches long, and I left about 6 inches beyond the pivot point. So and now you got here, coming down here, you got about 120 pounds of downward force, and that includes the 84-pound weight of the hydraulic press, plus the cart weighs 37 pounds, so that adds up to roughly 120 pounds. And you can think of it as a teeter-totter. You can imagine you got on one end of your teeter-totter, you got a kid weighing 120 pounds, and he's 16 inches from the pivot point. And on the other side of the pivot point, you only got 6 inches. So it'd take all the rest of the kids in the neighborhood sitting on this side to try to balance the 120-pound weight here, because he's farther away from the pivot point. And that sounds pretty safe, and it is, but you gotta understand the limitations too. Once I'm gonna back this up just a little bit. Once this cart starts to tip, if it tips this way, no, we're not going to tip that way, it's going to tip this way. If you put too much weight on it and it starts to tip, you can see that very quickly things get out of hand. This weight here that's hanging from the hook gets further away from the pivot point very quickly as it tips, and this weight here that's balancing it out gets closer to the pivot point. And so because the cart is tall, it can pretty quickly get unstable. And like I say, as it tips here, so you don't want it to tip even the tiniest bit. You don't want it to tip at all. And so you really got to be conservative. If you let your boom stick out even a little bit beyond the pivot point, it can get out of hand. And that can happen easier than you think. If you got it loaded somewhere near its limit, when you're rolling it along the floor and you hit a stone or you hit a pile of chips, of course I never have chips on my floor, but or you hit like even an expansion joint, it can start to tip and then it can get out of hand in a hurry. So the way mine is designed, you could hang well over 300 pounds on this point, and it would still be stable, but I would never load it that high. I don't plan to lift any more than about 100 pounds with the thing, even though it has 3 times that capacity. And then I think I feel pretty safe rolling it around, and as you could see earlier in the video, I could jiggle it around pretty good, and it stayed stable. So if you decide to build something like this, I'm sure you won't build it exactly like mine, but do the teeter-totter analysis and then be very, very conservative in how you decide to load the thing, and be safe. So that'll do it for this video. I know it's been a long time since the last one, but I'll try to make some more if you're interested. Meanwhile, thanks for watching.